What's up? It's your man, Jimmy Chan. All right, gonna try this again. So we're talking about quadratic functions today. So first to talk about quadratic functions, we're going to talk about the standard form of a quadratic function, right? That would be f of x is equal to a times x minus h squared plus k, where the a cannot be 0. Because if a was 0, guess what? Then you will only have f of x is equal to k. All right? Now, don't forget f of x is also, right, y, right? So it's the same thing as saying y is equal to a times the quantity, x minus h squared plus k. I'm hoping that this kind of brings back some transformation stuff for you. However, we're not actually doing the transformation itself. We're actually going to deal with the pieces and talk about those, all right? So first of all, before I talk about that, the a actually plays a very critical part of if it's going to be a parabola that opens up, and a quadratic, all quadratics are parabolas, right? So they're either going to open up, and when it opens up, that means that the a is actually positive. A is greater than 0 means a is actually positive, so it smiles. What a nice smile, right? However, if a was less than 0 or negative, then you get a frown, okay? So here's my two graphs right there, and that's what you see. And up here with the h and k, the h comma k would be your so-called vertex, okay? Don't forget, this is x minus h, right? And this is h comma k. That's your vertex. You're like, what in the world is a vertex? Well, your vertex is where it is the peak or the maximum or the valley or the so-called minimum. So this would be your vertex. Okay? So this right here would be your vertex. All right? So that's where your vertex is. All right? So if you notice that I have a purple line here, is a vertical line, and it cuts this parabola right in half. So it's called a line of symmetry. Same thing over here with a green line, green dotted line. It's a axis of symmetry. So the line of symmetry, if you notice that if I go through the vertex, right, that means this green line, right, if you think about what the equation of a vertical line is what? It's usually x equals, right? If it's x equals is a vertical line, it's usually the x value of that vertex, because a vertex is just a point. So the x is going to be the x value, which is the h, okay? And notice how I outlined this in purple and green, dotted, because this is a purple line and this is a green line, okay? So what else do you see on this graph that we've learned before? Well, there's a couple other things that you've seen before. One is the y-intercept. What do we know about y-intercepts? Correct. X is always equal to 0, right? And then we also have these two right here, right? What are these? These are the x-intercepts. And what do I know about x-intercepts? Correct. Y is equal to 0, right? And then over here on this end, so no matter if it smiles or frowns, there is still a y-intercept. Which says that x is equal to 0. And I do also have my x-intercepts. Which tells me that y is equal to 0, right? Okay, so at least I have those to talk about. So let's talk about these two graphs I've given you to label and everything else so that we can fill in what that line of symmetry equation is, right? All right, and what that HK, what the coordinates of that HK is, because you're not always gonna have a graph in front of you. Chances are you're gonna be given an equation and saying, hey, where is the vertex? What is the line of symmetry, right? All right, so let's say that the smile right here says that f of x is equal to, now I forgot what I put in here. Actually, let's work backwards. Let's work backwards. Hold on. Why do I want to work forwards when I can work backwards? All right, so let's name this vertex. All right, this vertex is what? -5, and I covered the vertex, and I believe that's 15. So this is -5, comma 15. Okay? So the x is going to be x equals -5. And it is a vertical line through x equals -5. Okay? All right, so I got my h and my k. All right? And so therefore, this equation right here, which I want to use red, is f of x, oh, actually, let's call this f of x since we're doing this one first. F of x is equal to, a is 1, so this is going to be x plus 5 squared plus 15. And you're like, why is it plus 5? Okay, so let's take a look at that. Why is it plus 5? The reason why it's plus 5 is because it is actually minus that -5, right? Because this is x minus h. So it's x minus a -5. So that's the reason why it would be x plus 5. Okay, so there's your equation. Now, actually, this is also a negative, sorry, because it's frowning. All right, so over here, let's call it, now we got to call this g of x. Okay, let's name this vertex. This vertex is 5, comma, -15. Okay, and the line of symmetry here is going to be x equals 5, which is the x value there. Okay, so this g of x is going to equal to x minus 5 minus, squared, minus 15. And there we go. All right, so we found the line of symmetry and we found the equation. All right, because the vertex is 5, -15. So there we go. And you're probably wondering, how do I know what A is? How did you know that the A is actually a +1? Well, I know it's positive because it's smiling. I know it's a 1 because I see the pattern here where the vertex, and then when you go 1 to the right, it goes up 1 as well. Okay, because if you think about the parent function, is the x squared as a parent function, right? Y equals x squared. So in this right here, if I do -1, 0, and 1, and if I square the x value, it'd be 1, 0, 1. So I have the point 1, 1, -1, 1, right? So if the vertex was at 0, 0, which I'm assuming right now, just based on this picture, not assuming anything else, just based on the points, that would be the case, right? And that's the reason why I knew it was a 1. And like I said before, like a transformation, it got shifted with my x's and my y's, so it got to this part of the vertex, right? Same thing happened here. If you look at this, it's a frown, but still, when you move to the right one or left one, it moved 1 as well. Now, if it was any other A, then it wouldn't meet those 2 points at all, okay? All right, so let's do an example. Well, so question is, what if we were given a traditional quadratic equation, right? So what if we were given f of x is equal to ax squared plus bx plus c. Again, a cannot equal to 0 because then it wouldn't be a quadratic anymore, right? So now what happens is that the vertex is actually negative b over 2a, comma, f of negative b over 2a. All right, so let's put this in perspective. All this is saying is, once you find b over 2a, plug negative b over 2a into the equation to for x to find y, okay? That's all that is saying, all right? So don't make that think that is confusing. That is exactly what it is. You gotta find the vertex. Now, here's my question. How would I find this piece right here? Wouldn't that be just my line of symmetry? Right? Because remember what we said about the line of symmetry, right? It's just the so-called x value up here, right? Because it's x equals. So if that's the case, then my line of symmetry is just negative b over 2a, or better yet, x equals negative b over 2a, right? So once I find my line of symmetry, I got my x value for the vertex, and then plug that into the equation to find my y value, and then I find my vertex. And the same thing happens here, guys. Yes, a can't equal to 0, but at the same time, if a is greater than 0, then I'm smiling. And if a is less than 0, then I'm frowning. Okay? Same idea there too. Okay? Now we get to talk about maximums, or maximizing and minimizing. Okay? So we actually got to talk about that as well. All right, so if I am maximizing, let me ask you this. Which of these two graphs would you suspect that would be maximizing? Correct, the frown, right? Because the frown actually has a so-called peak or a max, right? And usually they're going to ask you to maximize area. So we would look at the graph of the frown. In other words, it's going to be a negative a, or a is less than 0. All right? Because with the frown, this point right here would be, so where the vertex is the maximum. Okay. And if I was minimizing, the area, I would use a smile, which means that I'm going to have a positive A or that A is going to be greater than 0. So with a smile, right, I have the vertex here, right, which is the very bottom, the valley or the dip, right? So this is where the vertex is the minimum. Okay? And again, the x value is negative b over 2a, and the y value is f of negative b over 2a. All right, and don't forget, this is true no matter if a is less than 0 or a is greater than 0. So it doesn't matter if it's frowning or smiling. It is true for both of them. All right, so let's do an example for maximizing. Okay, so for maximizing, I'm going to have to write this problem out. All right, so David has 440 yards of fencing. To enclose a rectangular area. Okay? And what they want to know is to find the dimension to maximize the area. So that's part A. Part B, it wants to know what is the maximum area. Okay? So first, they want to know. There we go. So it's a rectangular area. That's all I know, right? They got fence 440 yards. So the fencing, where's the fencing going to go? Is it just going to lay right on top of this thing? No, right? It's supposed to go all the way around. So it's actually going to be, oops. It's going to go around like this, right? Boom, 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 boom. Right? It's going to go around that area. So 440 yards needs to cover this, right? So what I know, the only thing I know is it doesn't tell me what their relationship between the length and the width is, right? I don't know that. So let's just call this side X and this side Y. All right? So what information do I know about a rectangle? Well, with a fence, since it's surrounding it, then I must be talking about perimeter. Right? Now, yes, I know I'm maximizing area. I understand that. But the perimeter is X plus y plus x plus y, and that's going to equal to 440, because 440 is the amount of fencing I have that would wrap around this rectangle, right? Which would be the perimeter of that rectangle. So I know that 2x plus 2y equals 440. Awesome. All right. I know that the area is, let's say, equal to base times height. In this case, area is equal to x times y, right? Okay, so what can I do? Well, look at this, guys. Check this out. Don't I not have one equation and a second equation, right? I want to maximize area. So, and I don't know what the area is, right? Because it's going to want to know what the area is. So I really have two equations here. So my first one is A is equal to x times y. And my second equation says 2x plus 2y equals 440. This looks familiar. Two equations, two unknowns. What should I do? What should I do? Right? We can't do elimination, but we can do substitution. So since the y is at the end, I'm going to just solve for y just for poops and laughs. So I have 2y is equal to 440 minus 2x. I did that on purpose. All right, I would do it the other way. Negative 2x plus 440. So y is equal to negative x plus 220. Okay, so now I'm going to plug it in to my a function, right? So I got x times negative x plus 220. Okay, and when I put this together, I got a is equal to negative x squared plus 220x. Ooh, that looks like a quadratic, huh? Oh, wait a minute, look. Do you guys see this? A is -1, which means that this is a frown, right? So let's point that out right now. A is less than 0, so a frown. So that means my vertex would be a maximum. Ooh, right? Wait a minute. So what I can do is to find my x value, I can find my line of symmetry. So let's find my line of symmetry. Right? X is equal to negative b over 2a. Okay? So this will equal to what? Negative 220 over 2 times negative 1. So that's going to give me what? Positive 110. So that's my x value. That's my x value. So how do I find, so in other words, let me use another color here. So my vertex, oops. So my vertex now has an x value, 110. Now I need my y value. How do I find my y value? Anybody? 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 I gotta plug into one of these equations, right? If I plug it into the purple equation, am I gonna get a y value? No, because there's an a right there. I don't know the area. But if I plug into the second equation, I could, right? So 2x plus 2y equals 440. All right, so let's plug it into 2x plus 2y equals 440. Awesome. the x is 110, so I got 2 times 110 plus 2y equals 440. All right, so now I have 220 plus 2y equals 440. So 2y equals 220. So y is also equal to 110. Ooh. Awesome. So if I was to bring this rectangle back down, so let's go ahead and bring this rectangle back down here. Wow, that's such a nice rectangle, right? It's telling me that the x is 110. Oops, that's not the color. And the y is also 110. And so it's not even a rectangle, it's actually gonna be a square. So if I was to do this, I would go whoop, right? It's actually going to be a square. All right. So my dimensions is going to be a 110 yards by 110 yards. And my area is going to equal to 110 times 110 because it's base times height, or x times y in this case. So my area is going to be 12,100 square yards. Okay, so there you go. Yes, it seems difficult, but again, I am just putting out information that I know, right? It gave me the length of the fence, which would enclose the rectangular area, so it's going to be the perimeter. So it's giving me a number for perimeter, so I'm going to write down the perimeter. It wants me to maximize area, so area has to be the so-called function that I'm talking about. So then I go, okay, what's the area of a rectangle? Base times height, which is x times y. So now I got my two equations. So I need to solve, I would go substitution and solve for y and plug it into my area function. Okay, so once I plug it in, I see a quadratic equation, right? So, you know, in terms of a, and there is, I see that my a is negative, so therefore it's a frown. If it was trying to minimize it, well, chances are they're not going to minimize the area because that wouldn't make sense. Why buy 440 yards of fencing if you're going to minimize the area? Because then minimizing would be 0, right? So with area, chances are you're going to try to maximize it, which makes sense because if you only have so much fencing, you got to make as big of an area as you can. So there you go. So from there, I know that I can get my x value by doing the line of symmetry. And when I get my line of symmetry, I know now that I have my x value. And then I want to plug in my x value back into the equation of the area, right? I'm sorry, plug it back into the equation of the perimeter and get my y value. So now I will have my dimensions and my area. All right. Now, is there other problems like this? Yeah, but chances are the other problems are going to give you the function instead, right? So the function is already given to you. You don't have to actually figure it out. Chances are it's only the fencing and maximizing area where you actually have to create your own so-called equations. I hope this helps. If we got any questions, let me know. See ya. Bye.